SCIUS, I am one of the founding principals. It's a new company that was started really to address the transformational change that's happening in the construction industry here in Canada, which is where I'm based, even though it doesn't sound like I'm from Canada. This is where I'm at. You know, there's just so much exciting opportunity out there. So we've been working with governments, with progressive businesses in North America and increasingly around the world as they try to get to grips with, you know, essentially this analog to digital shift that's happening right across the board.
Fantastic. And are you working with construction companies and building industry? How much opportunities are there in construction to reduce emissions, and what proportion of emissions come from the construction sector?
Yeah, the opportunity is in the construction industry to make change, to improve efficiencies, reduce emissions. They're absolutely fantastic. It's one of the most wasteful, least efficient industries. It's only now getting to grips with digital practices, the sort of processes that the car industry or the shipbuilding industries have had for years and years and years. We're just really starting with right now. And I mean, if you want a few numbers, the construction industry, the built environment as part of the construction industry is probably responsible about 30% of the greenhouse gas emissions emitted today. So that's just operating buildings. So if you then want to load up all of the emissions associated with the construction materials and the construction process itself, you're looking at another 11%. So construction and the processes behind it, you know, 30 to 40% of your GHG emissions. And here's the kicker: about 50% of your average construction project is waste.
Wow.
It's non-value add. It's materials that end up in a bin. If you look at any construction project, whether in Australia or Canada or anywhere around the world, there's always a bin sitting outside with materials going in it that somebody has paid for, which is not going into the building. So, you know, and there are usually people standing about wasting time, again, money. There is energy being expended, again, waste equals money. And so we have to address all of those things. And GHGs are embedded in all of these things, just like money is embedded in all of these things. And so for us at SCIUS, it's just an amazing opportunity to really reframe the whole question about how we create buildings, how we manage them, and then how do we deal with them at the end of their life.
Do you think building materials and embodied carbon poses a different sort of challenge to operational energy, or a more difficult challenge than energy?
It does, in terms of the way you have to think about it. So if you think about the whole life cycle of a building, from you know, when the raw materials are extracted from the ground or harvested from the forest, you know, processed, often they're very energy intensive processes. So, you know, think about making aluminium windows and, you know, sheet glass and cement, for example, massive amounts of energy required to make all of those materials. Then you, having made them, have to ship them to the site, and often they're extremely heavy. So loads of trucks and transportation impact, you know, then it goes into a building, and the building itself operationally is a massive consumer of energy and emitter of GHG emissions. So all along the way, you've got this trail of carbon being emitted into the atmosphere. And then, of course, at the end of its life, it all gets scraped off the lot and into a bin and into a landfill if you don't have policies to protect, you know, from that. So yeah, loads and loads of opportunity to make a difference.
What are you touched on policies there? What policies are going to be most effective to incentivize project teams to be doing the right things?
Well, I mean, the top of mind conversation right now in North America is the whole idea about putting a price on carbon, and I think that's one policy for sure. But I think that the building industry is incredibly complex. I don't know what it's like in Australia, but you know, here in North America, it's primarily driven by very small businesses who've got quite small margins, they have to make a buck. They have to find the next project. And I think what we've found is that, incentives need to be meaningful for them to change the way they do business. And that starts right at the beginning when the client or the building owner is deciding to build a project, and making sure that they're adequately financed to pay for something that is really going to be able to stand the test of time. I think we found certainly in North America is that we're building buildings with too short a lifespan. And so they fall apart after 10 years. By 25 years, they really have to be rebuilt from the outside in or the inside out, replacing pretty much all of the materials that you put in at the beginning. And I think that there's a lot of policy being developed now to help owners understand what value and quality looks like in buildings. So, you're not just paying for the minimum standard permissible by your local building code. Mm. And we've struggled here in Canada that for some reason building codes become this aspirational standard that everybody wants your building to be meeting building code, and that's a good thing. Well, to be provocative, surely if it doesn't meet it, you should be going to jail. You should be getting a fine. You should be, that is not the standard we should aspire to. Just like, you don't buy a consumer product, just, does it turn on when you press the switch? Good, that's it. You want value out of this product, just the same. So I would say there's some rethinking to do, and policies play an important role in all sorts of different ways.
And it might also be like articulating that longer term value. So then builders and developers who are incentivized to just build it quickly and move it on quickly to the highest paying customer, if somehow those benefits were communicated that it's going to be a long-term higher value product and it's worth paying a bit extra for the upfront capital, I guess.
Mm-hmm. Yeah, no, it absolutely is. And I think that there's a lot that can be done to help everybody in the building industry understand what quality looks like and what value looks like. And it is interesting that there aren't good definitions of that, no matter how complicated the project or how simple the project. And it always, because it's such an expensive undertaking, and clients are just, so worn down by the process, the expectations on them, that the industry expects even the owner of a new house being built to somehow be more expert in the process than they are. It's unreasonable. And I think, like I say, the other major construction industries, and I always love the cruise ship industry or the shipbuilding industry, they have a completely different set of parameters. And whether it's the schedule or the value of the project or the expectation of the customer, it's managed very differently from the building industry, where good enough seems to be the order of the day. And that in this day and age, when we're worried about climate and waste, that's not okay anymore.
One of the things in Australia, Helen, is there's been a few new ways of measuring or embodied carbon impacts that have popped up. From your perspective, what's the best practice way to be measuring, and then from those measurements make the best design decisions?
So there are, it's pretty well established now, and there are ISO international standards around this process, and it's called life cycle assessment. And it's a scientific, well accepted approach that leading industry folks are pretty okay with now. They're pretty familiar with it. And what's really interesting is that the computing power and this digital shift in the industry is really helping to enable that. And really what it requires you to do is to track the materials that you specify, find the information about what's within that material or product in terms of its constituents, the processes and the various flows of GHGs in and out of that process, that manufacturing process, that transportation process, and then the building on into the life cycle. So life cycle assessment really looks at everything from extraction and harvest of the raw materials through to end of life. And it's a quantitative scientific approach that allows you to compare apples to apples and to rate and rank the different choices that as a designer you make in your building. I think that really is the only way. There's lots of kind of LCA light, but really the only way has to be to use the proper scientific approach.
Yeah, no, I'd have to totally agree with you on that one. And how do you see timber, particularly when it comes to materials, the role that timber has to play moving forwards for reducing our embodied carbon emissions?
Well, I think it's tremendously exciting. Being here in Canada, which is one of the world's timber powerhouses, and seeing how the industry, both the forestry industry and the construction industry, are coming together around this. If timber is supplied from sustainably sourced forests, which are managed under third-party or industry-accepted management practices, then you have a really compelling story to tell about timber and its role as a storage device for carbon. Here in Canada, the vast majority of the forests here are publicly owned. So in other words, they're under government control. And that means you can really impose some standards around how forests are harvested, how they're replenished, to ensure that you've got a really stable source of essentially a renewable product all the way through, forever, in theory. Now, obviously, there are lots of practical realities around that, and nobody has 100% story to tell about how saintly your product might be, and wood certainly has some GHG emissions associated with harvesting, kiln drying, prepping, finishing all the resins and so forth, but it's way better than anything else. And if I can just finish this thought for a minute, that when I was talking about numbers at the beginning, 11% of global GHGs come from the embodied carbon within products. 80% of that number is the structural products that go into the buildings. So timber as a structural product that's going to be there for 100 years, that is absolutely the choice you need to make if you're going to be building a building of the future that's going to be climate appropriate.
And you're right, 100 years is a realistic design life if designed properly for allowing for moisture. And we've done a few podcasts recently on durability. So if designed correctly with the right kind of thinking, you can get those extended lifetimes, because that is a concern I think some projects have, because concrete buildings, they'll also be there forever, but designed properly, timber's no different.
Well, it's again taking that life cycle perspective and making sure that you factor in the carbon inflows and outflows for your project, but certainly sustainably sourced timber. So of course, promoting Canadian timber in that regard, that really allows you the opportunity to tell a good story all the way through scientifically, and the numbers back it up. The interesting thing that we found is that, here in the west coast of Canada, in Vancouver, we're in a seismic zone. So we've got buildings here that were built in Vancouver over 100 years ago now that are 8-10 stories out of wood, like heavy timber structures that have sustained, in a seismic zone. And you just think, well, that's where you want to go, is you want to have projects that not only stand the test of time, but have the flexibility and to be able to withstand seismic events. So,
so
quite an interesting product for sure.
Absolutely. As we've been saying, timber will be able to help a bit with embodied carbon, but there's still going to be concrete foundations. You're still going to have steel in the connections. And so what do you see as the role of offsets going forward? Because we're inevitably going to have to get to zero carbon at some stage, and how are we going to actually do that?
Yeah, I know the whole offset thing is quite interesting, and I certainly think it's a good bridging measure. Anything that gets industry thinking about the price, the impacts that they have outside of the actual cost of their project, I think are a good thing. But I do know that there are, tremendous flaws with the offset program. It doesn't really drive change. It just drives a sort of a different economic model. So you have to be awfully careful that you're not just, still contributing to bad habits. There has to be a net reduction in GHG emissions now, right? We have a climate emergency, and addressing the material choices in your building means that you address that issue immediately. It's a short-term immediate win, because you're taking the heavy GHG burdens off the table right at the beginning of the project. If you are trying to just build a energy efficient project operationally, then you have to amortize those savings over the lifespan of the building, right? So a concrete, we'll just pick on concrete because it does have a GHG intensity to it, but there are other similarly intensive products. If you pick a concrete building that's very energy efficient, you've still got to deal with that initial investment upfront in a GHG intensive product that you then have to kind of recoup over the lifespan, and it doesn't always make sense. Mm-hmm. So, you know, it is a consideration, but I also think that you know, industry has to change its mentality, and offsets are not going to necessarily drive the change. In other words, you have to be directly, quantitatively changing your footprint today. And if you're not doing that, if you're just a little bit less bad than the one before, then you're part of the problem still. You're not part of the solution. And I think we have to get our heads around that.
Yeah, absolutely. I remember looking at the actual costs of an offset for, I think it was a steel car, and it's not much at all. Like the cost shift to offset carbon, the price changes, it's nowhere near as much as you think it would be. And interestingly, it's probably not enough to incentivize full changes across the supply chain to get to zero carbon.
Yeah, and you also have to remember that, you know, a building is a complex thing that's made out of many, many different materials. I mean, it's not entirely made out of wood. You know, the structure, yes, but, you know, it's clad in usually very energy intensive products because you want something that is weather tight, that's durable, and that's going to protect that wood structure for sure. So you do have to make sure that you're quantifying all of those decisions. I mean, we've got products now coming onto the market that address some of those issues that are, you know, lower carbon than perhaps other comparable products. And I think that's useful. But until there is an actual price on carbon, and here in BC and British Columbia, we have a carbon tax, and we've got that at around $35 a ton now. And that's, you know, and there's signals, long range policy signals that are saying that, you know, we need to be at around $100 a ton for this to really kind of bite and for people to be forced to make changes. But we're on the way, and it hasn't impacted the economy as much as you might think. In fact, we probably were doing 10% better on average than other provinces in Canada that didn't have that tax, because we're seeing an early shift to cleaner technologies. You know, so I think pricing is the main point here. It's not the tool necessarily, but pricing it is the most important thing.
Yeah, fantastic. Well, it's been an absolute pleasure speaking with you, Helen. Is there anything that you'd like to leave us with, or if people want to find out more about your research, where should they go?
Well, I'd be delighted to talk a little bit more about the research that SCIUS does. So you can find us at SCIUSadvisory.com. So SCIUSadvisory.com is our website. You can usually find me on LinkedIn, Helen Goodland. There's usually lots of chat about construction innovation of one sort or another. We're definitely involved with mass timber and timber technology. In fact, we've got a status report coming out for British Columbia on its timber technology sector coming out shortly. But we also play around in the world of digital tools, supporting that digital to industrialization process, and would be delighted to talk to anybody who feels the same way as we do about the future of construction and how exciting it really is.
Well, I'd love for you to just talk a little bit more about what is some of the most exciting research that you're coming across right now.
Well, obviously COVID has made things a bit weird for everybody, but what we're seeing is that there's an emerging approach to project delivery, which I think is really changing the way people are approaching construction, which has always been a very, and you'll forgive me because I'm allowed to say this, testosterone fueled process. It is, you know, when you go out on a construction site, and I'm an architect by training, and I've been in the business for 30 years, but, you know, you go out on a construction site and it's pretty male dominated. It's pretty, you know, the old white guy who maybe has very set way of doing things is changing a little bit now. But I do think that the advent of prefab, digital tools, and offsite construction is really changing the demographic within the construction industry. And I'm super excited about that. And we're doing quite a bit of work around the workforce of tomorrow, the skills you need, the opportunities that are there. And I think, you know, for people who don't see construction themselves as people in construction, it actually is changing pretty fast. And there's some fun jobs available now in you know, everything from renewable energy to, like you say, the wood industry is really taking off, and there's some fun and exciting industrialized projects that are coming out of the relationship between the construction and forestry sectors. So I think it's super exciting, and we're certainly right involved with those workforce dynamics which are happening.
Phenomenal. And I'll put a link to SCIUS in the show notes, or the specific link that it goes to all that exciting research you've been doing.
Yeah, that would be tremendous. Thank you.
Well, thank you so much for coming on the podcast. It's been an absolute pleasure to meet you, and no doubt I'm going to bump into you one day when the world opens up again and international conferences start kicking back up.